it's Jay again, your aviation instructor, and welcome back. This is segment 3. The first 2 segments we discussed some basic terminology and definitions used in composites. Segment 2, we've covered the 3 types of materials that are commonly used in aviation composites: the fibers themselves, the matrix system or resin, and then finally core materials that add additional strength and rigidity to the part. We've looked at a Black Hawk rotor blade that incorporated all of these parts. And remember, we always select our parts, our chemicals, and follow the procedures that we find in the manufacturer's manual, structural repair manual, or other approved data. At this point, we need to talk a little bit about how these things are combined in the right way to achieve that known good result. Following the steps and procedures is critical. It's critical because we can take wonderful materials and make a bad part. So the idea is we need to follow the instructions that the engineers have already pre-engineered and designed to ensure that that part is safe and airworthy. In order to do that, we need to understand a little bit about what the engineers do so we can understand what we do. One big term used in composites is fiber science. Fiber science, by definition, is the selective placement of fibers in order to achieve the desired results. Well, who does that? The engineers. They study how the fiber strengths work together and the orientation, and that's a key term. Orientation of the fibers need to be laid out and designed in order to get those desirable qualities. So let's take a look at some terms that deal with orientation so that we can always be in compliance with the fiber science that's determined how that part should be made and how that part should be repaired. We talked earlier about these 3 types of materials: fiberglass, carbon fiber, and aramid fiber, also known as Kevlar. Now let's look at some terms that deal with fabrics. See, carbon fiber, fiberglass, and aramid fibers are all textiles. They're woven products in this form, and there's some terms that come from way, way back that still apply to these modern fabrics. And the first term we need to focus on is warp. The warp is the direction of the fabric as if it was being unrolled. Most fabrics come in on large rolls or bolts, in some cases referred to as bolts, and as you unroll them, that long direction is the warp direction. It runs the length of the fabric. That's a critical definition, it's a critical word, because how we align these fabrics and fibers is based on that warp direction. So woven fabrics have a warp direction. They also have another direction that we need to understand the term, and that is the fill. The fill direction, if the warp direction is the long direction, the fill direction is the cross direction. It's coming across the warp. As a matter of fact, warp and fill are at 90 degrees to each other. And then finally, the last term is the bias. The bias would be an angle across the warp and fill. But of those 3 terms, the one I really want to make sure that you focus on is the warp, because that's the direction we use to properly orient these materials when we're making and repairing composite parts. So fiber science determines how the fabric should be warped, and textile definitions describe what the warp is. Our job is to make sure that we warp it in the right way, and often we will use what's referred to as a warp clock. A warp clock could be something as simple as a lightweight piece of sheet metal with the markings at 0 degrees. Your warp is 0 degrees. Your fill is at 90 degrees, your bias is at 45 degrees. Well, let's just focus on the warp. If we make a compass or warp clock, any object, we'll put 0, 90, 45 positive, 45 negative. Now, when you go to your structural repair manual, it will call for the right material and the warp direction. Now, when we go to that manual, it'll also indicate the warp direction for the whole part. So if we were to warp at 0, what that means is we're going to run the warp direction of the fabric perfectly in alignment with the warp direction of the overall part. That is known as basically orientation or warping. Each manufacturer's manual will tell you what each ply should be made out of and what degree the warp should be oriented. It's always very important because remember, fiber science determined that these materials have to run in a certain direction, and the warp direction is the most important because it also happens to be the strongest direction of most fabrics. When fabrics are woven, often there's more fiber running in the warp direction than in that crosswise or fill direction. Therefore, the warp direction of the fabric is stronger than all the other directions. That's why that's a key factor in making these decisions. A little later on, we're going to start and manufacture a part. We're going to build a basic part, and I'll show you how the warp plays a major role in laying out these materials. Now, I will tell you this, most good quality materials will indicate the warp, especially carbon fiber, by sewing in threads of color, so that once you cut this piece, if it gets turned, it could be very easy to get confused. By incorporating those woven fibers of a different color, we can keep track of what the warp direction is. But I always tend to make marks so that I don't lose my warp orientation, because I know if I don't get it on there the right way, it's not an airworthy repair. We're in the business of creating airworthy repairs at all times. So the next time we get back together, we're going to take these terms, these materials, and some basic technology, and we're going to work together, and we're going to build a basic part. I'm going to use most likely carbon fiber, fiberglass, and our foam core. And if you're at home and you're thinking, I really would love to build a cool composite part, I'd love to do this, that, or the other, I'm going to give you some basic knowledge, and you can order these materials, and you can do quite a bit of this work without any advanced or special tools. That's what makes this awesome, is the fact that composites can be manufactured often with basic tools, head full of knowledge, in a smaller space. Many aircraft over the years, especially experimental, have been built out of composites because the tooling required is so much less than when metallic structures. I love them both. I love airplanes. So I'm happy to work with either one, but I really enjoy the composite work because of the fact that the parts are a lot of times easier to build, and in many cases easier to repair. I appreciate your time. I look forward to having you back, and we'll catch you on segment number 4 dealing with making a part.